Okay, you are looking at the video lesson that is going to show you how to work with special equations that have different types of solutions, or I call them special cases when they come up. It is Unit 2, Lesson 3, so make sure this goes in your notebook where 2.3 is supposed to go. And remember, you are going to learn how to solve equations that have special cases. So the first thing we're going to fill out is the note sheet where it says the blank of an equation is the value of the variable that makes the statement true or the equation true. And this is just called your solution. This is the answer that we're used to getting. And so far you've done a great job with your assignments where you've used the answer bank to check your solutions, or you've put your solutions back in the equation to check them. So up till now you've always had one solution, and that is a case that comes up, but that's the only one you're used to at this point. So what I have here is a little area where you can kind of keep track of what the special cases might be. So it is a case that you'll get a solution, but you're going to learn today that there's a special time when you will get no solution, or you might get infinitely many solutions. So fill in this area here. You can put the little cloud around it if you want, and some little asterisks, because it is important. This is the brand new part. You wouldn't have learned about this in 7th grade at all. So this is brand new to 8th grade. Now, below that, I wanted to make sure you knew what our equations normally look like. So I picked an equation that has variables on both sides. And in this type of equation, remember, you're only going to get one solution. So if we take this equation, we see variables on both sides. So I first drew my locker, and I said, okay, I could move the 2x, but the variable on the other side that's actually a little bit smaller, I'm going to put my invisible 1 here. I'm going to get rid of that positive 1x. So that means I'm subtracting, remember to always do the opposite, subtracting the 1x from both sides. That allows this to cancel out. And what it does on this side, 2x's minus 1x gives me 1x. But remember, I don't have to write that invisible 1 if I don't want to. I do, however, have to bring down my minus 7 and my 19, which means I need to now move my 7. So you can see here that I did that. I have one solution. The only solution that works for this particular equation is that x equals 26. So again, guys, this is what we've been working on, and it does have variables on both sides as an example. Now the next section is going to show us how you might end up with no solution. So look carefully. What you have is something very similar to what we were just working on. 2x minus 7 equals 19 minus 2x this time. I think the first example I gave you a 1x, but I wanted to make this work out to show you what it looks like when there's no solution. So having a 2x on both sides, when you go to work through this problem, remember we always do the opposite. We go to subtract 2x. What happens is it not only cancels off this side, but it cancels off this side. So when you bring down, you realize you have a negative 7 and you have a 19 on the other side. Negative 7, guys, is never going to equal positive 19, and that's the indication that you will have no solution, when the two sides of the equation are never going to balance out, but you did have the same variable to begin with on both sides. So that's typical of a case where you'll have no solution. So jot down that little example in this section. And then at the very bottom, we're going to look at an example that has infinitely many solutions. So this means any value will work for that variable to make the equation true. It means this equation is balanced, and it's never going to become unbalanced no matter what you plug in. So I started out with the same type of equation, 2x minus 7. But guys, on the other side, what I did is I gave you a negative 7 plus a 2x. So again, working with the steps that we use when we have variables on both sides, you go to move your 2x, and what happens is it not only cancels off this side and this side, like before, but notice what happens when you bring down. You have a negative 7 on this side and on this side. Okay, negative 7 is always going to balance out with a negative 7 on this side, so I'm going to leave my equal sign here, and that's going to tell me this is a different case. Okay, back here they were not balanced, so that's why we said no solution. Right here, they're going to be balanced no matter what. So that's where the answer of infinitely many solutions comes in. And that's what you would actually write down, that this equation has infinitely many solutions. Not one solution, not no solution, but infinitely many. So guys, on the other side of your note sheet, what you have at the top is some examples. And what I want you to do first is I just want you to make sure that you see there's parentheses, and they still have to have the parentheses done first like we did earlier in the week and even last week when we were practicing, because we need to simplify both sides of the equations first. There's really not much going on over here. There's a lot of work going on over here between the distributing. And then what I did next is I combined. We have a 13 and we have a negative 12 to combine. And then this should look pretty familiar to you. You have one plain constant term and a variable. On the other side, you have another variable and another constant term. And this is what we've been focusing on this week. So at this point, noticing variables on both sides, we usually want you to move the smaller of the two variables. So I'm going to choose to move this positive 2x. So again, I'm going to subtract it from both sides to get rid of it. 4x minus 2x is 2x. Here's my negative 7 that I brought down. Here's my 1. And then from here down, remember, it should be home free. You can move your constant term, and you can divide. So again, this is the typical question that we get a solution for. So it's not really a special case. It's what we're used to, but we're going to stick it up here in this category, okay? It results in where your variable's on one side, and you actually have a numerical solution on the other side. So this would have one solution, and it's x equals 4. The next question starts out looking pretty complicated, but there's no parentheses. So remember, you don't have to distribute unless there is parentheses. But you can tell that it's really crowded on this side and it's really crowded on this side, which means we do have some combining to do. So positive 12 minus 8 gave us 4. The 2x and the 2x gave me 4x. Now you might be ready to look at the strategy we use for variables on both sides. We have a 4x plus 4, but then we have a 4x plus 3. So your strategy when there's variables on both sides, guys, is always to cancel out your smaller variable, but in this case they both match, which means they're both going to cancel out, leaving you with a 4 over here and leaving you with a 3 over here. Guys, 4 is never going to equal 3, so that means, put your not equal sign in there to remind you, it means your final solution is that there is no solution. What happened is the variables canceled each other out because they had the same coefficient, and then both sides of the equation were brought down, and we notice they are not the same. So when those constants are not the same, you're going to automatically know there's no solution. So we have one more example to go through, and this one starts out with some distributing where you have to clean up, some combining like terms where you have to clean up. And then again, we have variables on both sides. So working with our 14x and our 14x, you see they cancel. And when you bring down, you do have a balanced equation. So remember, this case is different from the other two. You don't have one solution and you don't have no solution. You have what's called infinitely many solutions. You will always end up with infinitely many when this happens. In other words, the variables cancel out, but both sides of the equation then are the same. You end up with that same constant at the bottom. So infinitely many is what it should say. And then please go ahead and cut your note sheet and make sure you tape it into your notebook in the proper location. You have a practice sheet that goes along with this assignment. Same number, 2.3 is the section and the unit number, so you'll be working on assignment 2.3 for your practice sheet.